Greetings, everybody. I'm Dr. Kotz. Great to see you again. Tell you what, as we go through residency, just keep this in mind. You want to get a good idea of what quantitative analysis is. And I'm going to try to give you a lot of the ideas that deal with business mathematics, number one, and then make sure that you have a great introduction to descriptive statistics, which really describe what's done historically or data that you could summarize with, let's say, the mean, median, mode, standard deviation, the range as some examples. But then the goal as we continue through the residency toward the end of the 5 days is to complete a problem set that deals with case scenarios that you might see for your dissertation or in business or education. And some of the examples will deal with, all right, how do you find if there's a difference between two groups? Let's say in reading comprehension, you have one teacher who uses one method and another teacher who uses another method, and you have their scores at the end of the year or a formative test. How do you see if there's a significant difference between, let's say, how the students perform? That's one example. Maybe you're doing a pre and post test, and we could run what they call a paired t-test. If you're just finding the differences between two groups, it's usually a two-sample t-test. If you're trying to look at pre and post or before and after, like, oh, how did you do on this manual dexterity test at LA Fitness? And then you go through a 6-week program, and then they measure your dexterity afterward, and you record it for a number of people. That would be a pre and a post test. We also hear about that in education too, and in business, where you might give a survey out at the beginning of a seminar. And after they go through the seminar and the wonderful training that is provided, you do a post test to see what they picked up. That would be a paired t-test. Okay. Those are very common in our doctorate in leadership program that students exercise and put in use within their own dissertations and as practitioners in industry and education. Those are called parametric tests. And the reason they're parametric is we assume they're based on a normal distribution. If you've talked to any of our colleagues in the program, such as Dr. Wolf or Dr. Feder-Lewis or Dr. Hines or Dr. Siseski or Dr. Teklamariam, Dr. Pai, and Dr. McClure, it's always good to draw yourself a picture or a graph and say, does this form a nice bell-shaped curve? If it doesn't, maybe you have to use something else because it's skewed in nature of the data that you collect. So I hope that helps you. The idea of descriptive statistics, parametric tests, just as an introduction. But our hope is that you can complete those first two problem sets and get a good idea among your colleagues to set up some teams for yourself that you can refer back to, especially if you get stuck. Our hope is to use Minitab. Minitab is a great software package, and it's available to our St. Mary's students. But I'm not holding you back from using Excel or another package that fits you well. Remember, we're not trying to make you into a calculating guru or genius. What we want to do is be able to use the software so that you can make effective decisions. And that's the key, especially at the doctoral level. You want to be able to interpret the results. So that's our major goal. If you have any questions, you just reach out. It's a pleasure to work with you. Talk soon.